Hey, how's it going, everyone? Welcome back to day 4 of the 30-day Lead Code Challenge. My name is Taha, and if you haven't already checked out the last 3 videos that I posted, they covered detect capital, design hash set, and valid palindrome. So if you haven't checked those out, be sure to do so. They're pretty important interview questions that come up fairly frequently. So today, we're looking at a question called power of 4. It says, given an integer signed with 32 bits, write a function to check whether it is a power of 4. So basically, if you're given a number like 16, you return true because 16 is a power of 4 and 5 isn't. So there are 2 approaches to this question that I want to show you guys how to implement in Python. The first one is a more mathematical approach, and the second approach is more iterative, using a while loop. First, I want to explain my thought process behind the mathematical one, because this is the first solution that my brain kind of just automatically started to think towards, because when I looked at this problem, I decided to work backwards. So let me show you what I mean. So I've just listed out a couple of powers of 4 here. 1, 4, 16, 64, 256. So what I kind of logically think right away is, okay, we're given some number x, for example, that's equal to one of these numbers. Or it could also be a number that's not a power of 4. It could be 7, it could be 5, whatever, right? So my thought process about how to solution this started from thinking, okay, we need to find out 4 to the power of what can give us the number that we're looking for, 64, for example. Now, right away, this is a pretty simple exponential function. Now, if we just use some basic high school math, we know that if we log both sides of the equation, we get log 4 times x equals log 64. Okay, so x equals log of 64 divided by log of 4. So basically, if this little equation returns us a positive integer, then we know that the inputted number is in fact a power of 4. All right, so we're simply going to take this little equation here and write that in Python. Also, another thing that we know about exponential functions is that it can never equal or be less than 0. Remember, the graph looks something like this. We have our y-axis and our x-axis, and an exponential function is something like this. So it never goes to 0 or below 0, right? So right off the bat, we can say that if num is less than or equal to 0, we are going to return false. And taking that little expression that we derived from the logarithms, we know that the exponent that we're solving for is equal to math.log of the number that we're given divided by math.log of 4. Let's also just import math. Now the last thing that we have to do is check whether this exponent that we've just calculated is actually an integer and not a floating point number. So to do that, we're going to use a built-in function in Python called exponent.isInteger. And we'll return this. All right, so let's just run some basic tests on here. Let's see if 256 works. All right, that returned true. Let's see if 12 works. That should be false. Okay, and 0 should obviously work as well. Now let me submit the solution and show you the runtime and space complexity. All right, so we can see that it's better than 88% for runtime, which is all right. And it's better than 47% for space. If you guys have any suggestions on how I can improve space for this specific algorithm, comment below and let me know. With that being said, let me show you the second solution that we can possibly implement to solve this problem. So here's the approach we're going to take. So let's say again you're given the number 64. Okay, this time we're going to check if this number is divisible by 4, then we'll divide it by 4. So 64 over 4 is 16. Again, if this is divisible by 4, we'll divide it by 4. And the idea here is we'll keep dividing by 4 until we reach a number that's not divisible by 4, or we reach number 1. So if we keep going in this example, we're going to get 16 over 4 gives us 4. And then if we divide 4 by 4, we get 1. So let's say we started with a number like 67, for example. This is not evenly divisible by 4, right? You have some remainder. Therefore, this number can't possibly be a power of 4, so we're just going to return false here. All right, so let's implement that in Python. I'm going to comment this solution out. So actually, we can actually just keep this line because this logic doesn't change going across solutions. So what we want to do here is check if the number that we have is evenly divisible by 4. So if num mod 4 gives us 0, then we know we have a number that's divisible by 4. In that case, we'll just divide num by 4. So by the time this whole process is done, we either have a number that's equal to 1, and if that's the case, then we'll return true. Otherwise, we will return false. And that's basically it. Wow, so this one actually got better than 96%. And the space complexity is a lot better as well. Okay, I actually didn't get these numbers the first time I submitted this question. I guess now that there's more submissions that have happened in the past day, the chances of me getting a better submission is higher. So yeah, if you guys have any comments about how I can improve either the first or this set of code, then definitely comment below and let me know. If you guys learned anything new in this video, it helped you out, or you just enjoyed the process of solving the problem, please feel free to like and subscribe. Thank you guys. I'll see you in the next one. Bye.